Okay, so everybody's going to have 5.1 there. If you think that, I mean, I think it's half a meter. We could have been off by, where's Kevin? There he is. Weren't you measuring that with me? No, it's Connor. Yeah. Connor was measuring that. Well, don't you think we could have been off by half a meter? Yeah, we wanted to get inside, we weren't being all that careful, right? Okay, this is going to be your mass, so you're probably not exactly 73 unless you happen to be 160 pounds. There we go. These are my times, right? So my very first calculation is I just want to average those times. So get out a calculator and just add them up and divide by 4. So this is how you can tell who the real nerds are, because they'll actually use the average function or something. 3.83, we think that was like a short time, but I'm going to go with it because it bolsters my ego slightly. And then I'm going to divide by 4. So I'm going to say that it's, 4.32. Right? And then my uncertainty is going to be the Russian judge minus the U.S. judge. Remember, the low score is good, right? Okay. Russian minus U.S. over 2. So 4.57 minus 3.83 divided by 2. So 0.37, I'm just going to say that it's 0.4 because for me. So feel free to take your, whatever the range is, you could round it to one place. That's entirely adequate. So for sure, what I'm saying is that the time for me to climb those stairs is 4.32, for sure, plus or minus 0.4. That my best time lies in there, don't you think? Probably closer to plus than minus at my age. Yeah. Just take the highest one minus the lowest one, divide by 2. So that's going to be high minus low divided by 2. This is my high. This is my low. If all of yours were incredibly consistent, you might have a very small uncertainty. Some of you guys were running like always the same number. Are we good? Does everybody have a calculator? Is everybody calculating along? It'll never get easier than this, right? The second part, are we on number 1, calculate your power output? I don't know, what is that? What is that crap? It's a trap. Why is my paper all wrinkly like that? Because I was having so much fun, I was crying on the paper. They were tears of joy. Calculate your power output. Okay, so let me just show you the best guess power output. Put your calculation right here and just show you I'm getting all emotional now. Either that or I need a drink of water. Okay, you want to know a nerd joke? Cop pulls over, so Patrice Suen thought this joke up this morning. I thought it was really funny. Okay. Cop pulls over an electron, right? And of course there's a stock phrase, right? Do you know how fast you're going, right? So sure enough, the police officer walks right over to the side, the electron, rolls the window down, like, okay, And the officer says, do you know how fast you're going? And the electron promptly says, wait, I gotta get the punchline right. And the electron says, no, but I know exactly where I was. Because of the Heisenberg uncertainty principle, it states that you cannot simultaneously know the velocity and position of a very small object. Yeah? See, it's funny if you know that whole Heisenberg uncertainty principle thing. Right, so let's say the punchline again. Did you know how fast you're going? No. Because they didn't know their momentum. But I knew exactly where I was. That's the position, see? Isn't that funny? So if you have parents that are like quantum physicists or just physicists, that's a real knee slap, right? It's just like... Okay, let me show you how to calculate the best guess power. The best guess power is going to be these numbers here. right? So it's mgh. I'm using this formula, mgh over T. So my best guess mass is 73 kilograms. My best guess 9.8 is 9.8, right? My best guess height is 5.1. And my best guess time is 4.32. Right, so for your best guess, hit me with your best shot. Right? Yeah. Use all the numbers that you think they are, right? So you're going to use this guy, this guy, this guy, and you're going to get an awesome display of power. And these are, of course, joules per second, because the numerator is joules of energy. This is seconds, right? Now, and notice that this is significantly higher than a horsepower. And likely, if you tried to run fast and you are a heavy person, that you probably are well in excess of a horsepower. Horsepower is 745.7 watts. Right? How is that possible for me to put out more than a horsepower? Say it again. It is possible. It's not. It's a calculation error. It is possible. How is it possible? Greg LeMond can do it for like 3 hours. I can do it for 5 seconds. Maybe. Who knows, right? Yeah. So isn't it maybe just a short burst of energy that we're capable of? Why can you do that? Why can you put out a short burst of energy, but then you get tired? Do your muscles store energy in their own cells? Yes, they do. They store energy, and of course adrenaline releases that instantly, right? So you can run away really fast. But of course, you can't maintain that pace, I'm guessing. Right? So that's what your heart, that's what conditioning is delivering new stuff to your muscles. But you can do short bursts of energy for short time. So yeah. You know, a sprinter is going to beat them up the stairs, right? But if the stairs went up to the top of Mount Hood, Greg LeMond or a marathon runner or something like that's going to beat them, right? Because it's the long fiber muscles and the conditioning and all that stuff, right? You know. But for this, you know, if you're like a sprinter or something, you're going to just peak out for your power. So that's, you know, there we have it, right? That's the question down here. How do we get the highest possible power? What do we do?
Use our lowest time.
Use our lowest time. So I'm going to use my lowest time, right? 3.83. So that's easy, right? Use your lowest time. And then what do I do with my mass? I don't think that I was 73 kilograms. I think that I could have been as much as...
like 75.
75, there we go. Why 75? Because that's 73 plus 2, right? 9.8 is still 9.8, right? And then the stairs, maybe they weren't 5.1 meters tall. How tall could they have been? 5.6, maybe they were that tall, right? 5.6. That's going to be a big number. 75 times 9.8. Divided by my smallest time. So you do this, of course, obviously you want to do it with your numbers. That's 1,075. I like that number better. But of course, the real question here is what's the lower limit? Because we probably don't believe that it's really as high as it is. So the question here is we can figure out as the lowest it could have been and still remain incredulous about this, right? So what is the lowest mass I could have been?
Let's see. You can bet anyone.
If I'm 73 plus or minus 2, it's a trap.
It is a trap.
We were sent to check on signs.
You may or may not have some answers.
I've got signs.
You've got signs.
Science has signs.
If some ASB officers wandered in around 2:40, borrow them until 3:20.
Oh, are you talking about like standing outside and et cetera?
Maybe.
Yeah, they're in the science office, but yeah,
Okay.
yeah,
This is hypothetical.
hypothetically speaking, yeah, yeah, right.
Thank you.
This air will self-destruct after we've used it for our conveyance. However, this is live on YouTube, so we got nailed for this, right? Okay, so my